In this video, we will look at differentiating inverse trigonometric functions. Suppose we have y equals sine inverse x. What is the derivative of this function? And no, it is not going to be cos inverse x. Let's try to find the rule for this. If y equals sine inverse x, we can take the sine of both sides as shown. So we have sine y equals sine inverse x. On the right, the sine and the sine inverse cancel, so we have sine y equals x, or to make it clearer, x equals sine y. If we imagine for a moment that the role of x and y are swapped, we can think of the following as being identical to y equals sine x and finding the derivative. Instead we have x equals sine y. So the result is dx dy equals cos y instead of dy dx. But we are looking for dy dx, so we shall invert both sides and we get dy dx equals 1 over cos y. However, we need this to be in the form of a function of x, so we replace the y with sine inverse x. And we shall rewrite the x as x over 1, so we have dy dx equals 1 over cos sine inverse x over 1. You may remember from semester 1 we saw how to calculate cos sine inverse. What we do is draw a triangle with opposite x and hypotenuse 1, and using Pythagoras theorem we have the adjacent being square root 1 minus x squared. So the cosine for this triangle would be the adjacent over hypotenuse, which is square root 1 minus x squared over 1. So the result is dy dx equals 1 over square root 1 minus x squared over 1, or in other words dy dx equals 1 over square root 1 minus x squared. So we have the result. The derivative of sine inverse x is 1 over square root 1 minus x squared. The proof you've just seen can be repeated almost identically for cos inverse and tan inverse. It'd be rather redundant to show you this, so instead I'll give you the results from those proofs. We've just seen that the derivative of sine inverse x is 1 over square root 1 minus x squared. The derivative of cos inverse x is minus 1 over square root 1 minus x squared. And the derivative of tan inverse x is 1 over 1 plus x squared. Let's look at some examples. What is the value of the derivative of y equals x sine inverse x at x equals 0? Y equals x sine inverse x. We do the derivative, but on the right we need to use the product rule. So that is derivative of the first function, keep the second function the same, plus keep the first function the same, and the derivative of the second function. The derivative of x is 1, and the derivative of sine inverse is 1 over square root 1 minus x squared. Now we have to evaluate this at 0, so we put 0 into this expression. 1 sine inverse 0 plus 0 times 1 over square root 1 minus 0 squared, which is in total equal to 0. What is the value of the derivative of y equals tan inverse x over x at x equals 1? Pause the video and try this one. Y equals tan inverse x over x. We will need the quotient rule here. Bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. So we have x times derivative of tan inverse, which is 1 over 1 plus x squared, minus tan inverse x times derivative of x, which is 1, all over x squared. Now we put in 1, so it's 1 times 1 over 1 plus 1 squared minus tan inverse 1 times 1 all over 1 squared, which gives us a final answer of a half minus pi over 4. That's all for this video.